Good afternoon, everybody. First, thanks very much for giving me a chance to present my work. But my oral English is very poor, so if you don't understand what I say, you can email to me. My talk about quantifying contributions of external forces to climate change over China based on simplified models. This is the outline of my talk. First, I give example introduction. We know that the climate change is caused by internal climate variability and a response to external forces. Many studies have confirmed that the human activities caused the climate change since from 1950s. Some recent studies confirm that many weather and climate extreme events over China are contributed to human activities. However, few studies focused on the quantifying the relative contributions of human activities and natural external forcing to observed climate change over China. So, my work focuses on the following three questions. One is, how will the simplified models simulate the observed variation of temperature and precipitation over China? How much the individual external forces contributes to the recent change in observed temperature and precipitation over China? How significant the contributions are estimated from each external forces? This is data. The observation-based data sets, including the latest version CRU and the GPCC. We also use reanalysis datasets such as ER interim and the mirror to compare with compared and check the quality of the observation-based datasets. The model simulations from 10 models of simplified project, which is including here. Only about these models conduct the single external forcing experiments. The study period is from 1951 to 2005. Next, this is data and a method. We use a step regression method to estimate the contribution from each external forces. The delta means the difference of this period minus this period, and the regression coefficients estimated by each external forcings respectively from 1951 to 2001 based on 5 years smoothing annual anomalies using the stepwise fit method. So the sequence in estimating these regression coefficients merely depends on the explained variation for observation. We also use a EMD method to estimate the nonlinear trends and compared the simulated results with the observation. We also use optimal fingerprint method to detect the significance of the contributions. First, we use the observation evaluated at the model simulations. We know that most simplified models can well capture the observed long-term mean and seasonal changes, as well as the long-term trends. But the simplified models have shortcomings to represent the observed internal variability. Here shows the UF patterns of the temperature. This is observed result. This is model simulations. The model simulations can well capture the global warming mode derived from the observations. This is a precipitation mode, because model simulations shows a difference over here. The large difference between them in PC's long-term changes. The model simulations shows clearly increased tendency associated with global warming, while the observation represented variations still determined by internal climate variability. This shows the quantifying the contributions from each external forcings. This is temperature results. We can say that the observed changes merely determined by the greenhouse gas. The aerosol also play important negative effects for the observed change. Their total contributions are very close to the observations. The particularness is very higher. This is regionally we can each external forcings contributions are different, but merely contributions arrive from the GHG and aerosol. So both anthropogenic and external natural forcings account for about 95% to 99% of the observed temperature changes during this period. Unlike the temperature, we can see that the observed precipitations are merely caused by the aerosol, because this region, the aerosol play an important role in the observations. Other external forcing also have some impacts, but the impacts are very locally. The total contributors is also very consistent with observations. The total external forcing can explain about 65 to 78% of the observed changes over the past 50 years. Aerosol and greenhouse gas still are the primary external forcing leading to the precipitation changes. This is long linear trees. We can see before before about 1970s, the long-term nonlinear trends in the temperature changes are primarily dominated by the greenhouse gas aerosol at net in most of China. After about that time, greenhouse gas gradually becomes the most dominant factor, while the effect intensities of the aerosol and the net gradually decrease. Yes, okay, no problem. This is precipitation. Greenhouse gas are also primary weighting factor. The aerosol-induced nonlinear trends in precipitation are relatively stronger in humid and semi-humid regions. We also use the optimal fingerprint method to detect the significance of the contributions from each external forcing factors. This just shows that the human activities can be clearly detected in temperature changes in each regions, while the effects of the net is not detectable. The greenhouse gas effects can be separate from the combined effects of all the other external forcings. The individual effects of the aerosol and the land use cannot be significantly detected, while the combined effects of all other forcings can be clearly detected. But this method cannot be used to detect for detection and attributions for precipitations discussion. There are still many uncertainties in our work due to the method used to estimate the contributions from external forcings. Next is uncertainties in external forcings and model physical deficiencies. So it is still need to dynamic downscaling use regional climate models with high resolution. The shortcoming in my research is not considering the impacts of the internal climate variability. So the internal climate variability plays an important role in recent climate change, especially in precipitation changes. So in the future, we will fully consider the impacts of the internal climate variability. That's all. Thank you.
Thank you. Are there any questions? Others? Yeah, Linda, thank you.
Yeah, I didn't. Your second point in your concluding slide about the need for using dynamical downscaling with high resolution. What, I guess, given the scale, the continental scale, and the scale at which these forcings operate, what difference do you think the dynamical downscaling would make, and why do you think that's an important
yes, good
step?
questions. This is use low resolution, all the resolutions, but for the locally, it should be use high resolution to estimate the contributions of external forcings. Some for locally, if we still use the global GCM results, maybe some effects such as land use cannot captured
Ah, I know. Okay.
Yes, the RCM has maybe play important role to capture the locally impacts of land use change. Yes, but the GCM cannot do this.
Oh, thank you very much.